Hello everyone, we are presenting our applied big data engineering mini project, a FinTech fraud detection pipeline. Our goal was to build a system that catches fraudulent transactions in real time in under 10 seconds using a Lambda architecture with Apache Kafka, Spark structured streaming, PostgreSQL and Apache Airflow. Everything runs inside Docker containers. This is our Lambda architecture. Data flows from top to bottom. Our Python produces sends transaction to Apache Kafka. Spark reads from Kafka every 10 seconds, applies our fraud rules and writes results to PostgreSQL immediately. That is our speed layer, real-time detection in seconds. Apache Airflow runs every 6 hours to generate reports. That is our batch layer. Together they form a complete fraud detection system. Here is our project structure. We have 5 main files. The producer script generates transactions and sends them to Kafka. The Spark fraud detector reads from Kafka and applies our fraud rules. The Airflow DAG runs the batch reporting pipeline. The init SQL creates our database tables, and the Docker Compose file starts all 8 services with a single command. Here you can see all 8 containers running. Zookeeper, Kafka UI, PostgreSQL, our producer, Spark Master, Spark Worker, and Airflow, all up and healthy. We started everything with just one command, Docker Compose up. The producer has been running for hours, continuously sending transactions to Kafka. Here are live producer logs. Every second a transaction is sent to Kafka. Normal transaction, user 036 spent $2,826 on travel in Sydney. User 027 spent $269 on clothing in Bangalore. And here at 9:50 a fraud injection is the user 041 spent $8,335 on electronics. That exceeds our $5,000 threshold and will be flagged as high value by Spark within 10 seconds. The top part shows our CSV report. Electronics leads with 713 fraud attempts, followed by online retail with 707 and travel with 693. Moving to Kafka UI, you can see our transactions topic has received 12,041 messages. Kafka has stored all of them durably on disk. Even if Spark restarts, not a single message is lost. Spark reads from the last committed offset and continues from where it left off. This is why we choose Kafka over other messaging systems. It gives us fault tolerance and replay capability. Here is the Spark Master UI. You can see fraud detection pipeline is actively running, status running for 10.4 hours. One worker is alive using 2 cores and 1 GB of memory. Spark is processing micro batches every 10 seconds, reading from Kafka, applying our 2 fraud rules and writing results to PostgreSQL in real time. Our system uses 2 fraud detection rules. Rule 1, impossible travel. It means same user in 2 different countries within 10 minutes. Rule 2, high value. It means any transaction over $5,000. Here you can see Spark processing live. Batch 1052 had 10 records, 3 fraud detected. User 015 spent money on online retail, travel and electronics, flagged as impossible travel. 7 valid records written to PostgreSQL. This is the core of our pipeline, fraud detected and stored within seconds of the transaction occurring. An important point here, Spark uses event time, which is the timestamp from the transaction JSON, not the time Spark received it from Kafka. We applied a 2-minute watermark to handle late arriving events correctly. Here is our Airflow UI showing the fraud ETL pipeline DAG. It is scheduled to run every 6 hours. You can see all 4 tasks: extract transactions, export packet, reconciliation report, and fraud analysis report. The DAG has run 8 times total, 3 successful runs and some failed runs during development when Spark was not continuously running. The green squares shows successful completions. Here is the diagraph view showing our task dependencies. Extract transactions runs first. It pulls all fraud and valid transaction data from PostgreSQL. Then the remaining 3 tasks run in parallel: reconciliation report, export to Parquet, and fraud analysis report. This is exactly how we design the batch layer of our Lambda architecture. And here is our main analytic deliverable, fraud attempts broken down by merchant category. Here is the reconciliation data from our PostgreSQL database. Here are the CSV files generated by our Airflow DAG. This is the fraud by merchant category report, our main analytic deliverable as required by the project brief. You can see all 10 merchant categories ranked by fraud attempts with total amounts and averages. This is the reconciliation report comparing total ingress validated transactions and flagged fraud. This is what a financial compliance team would review every 6 hours in a real production system. And this shows the breakdown by fraud rule: impossible travel detected cases and high value detected cases. To conclude, our system improved fraud detection from hours to under 10 seconds using automated real-time processing. We processed over 20,000 transactions, detected thousands of fraud events, and generated automated reports using Airflow. Our Lambda architecture combined Kafka, Spark, PostgreSQL, Parquet, and Airflow to build a complete real-time fraud detection pipeline at scale. Thank you.